And now, let's proceed to the last type of annuity, which is a special type. This is called perpetuity. Okay, suppose you are receiving a certain amount at the end of the month for life. A at the end of the first month, A at the end of the second month, and so on. But you changes your mind. You decided to withdraw all of this amount because you want to buy something, say a property today. So instead of receiving that at the end of the month, so you decided to withdraw it today. How much money will you have today? Take note that this cash flow is an ordinary annuity because it started on the end of the year's one. So calculating the future in the present worth all of this annuity, then we must have this formula. Present worth of annuity is equal to your A times this expression here. But observe that your N here actually is an infinite value. So we substitute an infinite value for your N. Take note that this is raised to a negative N. So raising this to a negative value will make the expression 1 plus I raised to negative N, which becomes 0. So when this value is equal to 0, the expression remaining inside the parentheses will be equal to 1. So we'll have A times 1 divided by I. So the present worth for the perpetuity will be equal to A divided by I. Okay, let us consider this problem. How much money must you deposit today in an account earning 10% compounded annually so that you can withdraw 25,000 yearly indefinitely starting at the end of the 10th year? Okay, so your plan to deposit money now, maybe you want to withdraw 25,000 yearly to be used by your son after 10 years. Okay, so at the end of the 10th year, you wish to withdraw 25,000 indefinitely from that bank. So you need to deposit some amount of money here and then withdraw that starting at the end of the 10th year until the infinity. So first we calculate the present worth of all of this annuity, and that will be the equivalent value of all of this annuity here on year 9. The present worth of all of this annuity is equal to A over I, which is the value equivalent on year 9. Observe that this is not actually the present worth of all of the annuity, because according to our formula, the present worth should be on year 0. But this worth is simply the equivalent worth of all of your perpetuity at the end of year 9. So instead of writing P here, we simply write that as L to mean that this is the equivalent lump sum amount of our perpetuity. Okay, since we have here an equivalent lump sum, we'll just only consider the lump sum and then calculate the equivalent present worth of that lump sum using this relationship. If we have a future amount F, we can calculate the equivalent present worth of that using this formula. In this case, we will simply replace our F with L, which is the equivalent lump sum of our perpetuity. And substituting the value of your A over I in the L here, and considering also our value of N. Our N here is not equal to 10 but is equal to 9. Your perpetuity starts at the end of year 10. And the equivalent lump sum of this perpetuity will be projected on the end of year 9. So therefore, your lump sum is at the end of year 9, which is the future worth of some present amount, P. So the future worth of some present amount is L, which is 9 years from year 0. So our end here will be equal to 9. So substituting the value of your L which is A over I, and they divide it by 1 plus I raised to 9, then you can calculate the equivalent present worth of all of that annuity. So that is the amount that you must deposit today in a bank to withdraw 25,000 at the end of every year, starting the end of 10th year.